Well, welcome back. Let's talk for a moment about how we motivate E for teenagers. Uh, you're going to have an Algebra 2 class. The Algebra 2 class is going to deal with E in some way, shape, or form. So how do we motivate E? There's only one canonical way to do it as far as I know, uh, and it's because of the following. So let's do some calculus. Let's remember that the natural log function is the integral from 1 to x of 1 over t dt. And so the derivative of the natural log of x is 1 over x by the fundamental theorem of calculus. And this means that the derivative of the natural log of x when x is 1 is 1. But by the definition of derivative, the derivative of the natural log function when x is 1, well, that's a limit as h approaches 0. Limit as h approaches 0 of function at 1 plus h minus function at 1 over h. This is the definition of derivative. Function at 1 plus h minus function at 1 over h. We know that this is 0. And so we can rewrite this. We can rewrite this as 1 over h times the natural log of 1 plus h. But you and I both know, because we teach Algebra 2, that this power that's in front came from up on high, right? And we know that this is 1 because that said so. So if this is true, and if the natural log function is continuous, then this implies that the natural log of the limit as h approaches 0 of 1 plus h to the 1 over h is 1. And that means that the limit as h approaches 0 of 1 plus h to the 1 over h has to be E. So E is, in fact, a limit. And we can bring that to a pre-calculus class without too much trouble. So what's the connection to our Algebra 2? Well, instead of taking a limit as h approaches 0, which is not very familiar to young people, take a limit as x approaches infinity instead. If we take x going to infinity, so h has to go to 0, so this thing has to go to 0, that thing goes to 0. And as h goes to 0, this thing gets large, this thing gets large. That's the other way we write E. It's a limit as x goes to infinity of this thing. But this thing is familiar to Algebra 2 students because it looks a lot like the compound interest formula. And this is where you get the motivation, where we're going to invest $1, because there's a 1 in front of here. We're going to invest $1 at 100% interest. Why? Because that's 100% interest. Compounded continuously. Why? Because this is getting larger and larger without bound for a year, because those numbers match. This x down here matches this x up here. So this is the way we generally motivate E for teenagers. We say, take $1, invest it at 100%, compounded continuously for a year, and you do that over and over and over again. And what happens? Oh, it gets really, really close to $2.72. Well, actually, it gets really, really close to $2.718281828459045 over the course of the year. And then we sort of wave our hands and say this E number is very, very important for reasons we will describe. The reasons we will describe are hidden up here, but an Algebra 2 student's never going to get that. You could try to motivate it off of the original picture. Here's 1 over x that we all know about. Here's x equals 1. So here's some limit that's some area that's 1. It's usually important for us to care about things of area 1, and the way to do that is to make this number e. That's much less satisfying to teenagers. Teenagers are like, well, why did I care about this function in the first place? And then you gotta explain, oh, well, because its derivative makes us do some really nice things later. And they're like, yeah, I don't really care about that. Um, right. So, I mean, you're stuck on that. There's not a lot that you can do that bails you out on that. I'm so sorry. It's just not helpful. Okay. So that's a little bit of pedagogy. It's why we talk about E in Algebra 2 in the way that we do, because all of the other reasons we care about E are just flat out not accessible to them. So why is E in the high school curriculum in the first place? I have no idea. I wasn't part of that. I'm sorry. I don't have a good reason. Other people might have better insight. Okay? So that's the lesson. When next we gather, we break into the world of complex analysis. We take a look at polar coordinates. We take a look at complex numbers. We take a look at geometry. We bring in some trig. It's uncomfortable. We'll get there. Don't worry. See you soon.